Hi, welcome to the Angular and Openlayers course. I will show you how you can easily implement maps in your application. The course will be based on the application you can see on the screen. I have prepared some basic functionality to start with. As you can see, there's geolocation, drawing features on a map and more. If you are only interested in code examples, I have included a link to the GitHub repository in the description where you will find the most actual version of this app. But if you would like to see the full tutorial, which of course I encourage you to do, I have also prepared there a branch called init to start with. We will build exact same functionality as this app step by step. One important note, the scope of this course is still evolving, so if you watch this video in the future, this repo may include much more features. If you have any suggestions, feel free to put them in the comments. Why did I choose Angular? I haven't worked with it for some time, so it's also like a refresher to me. But to be honest, there won't be a lot of Angular specific stuff, so you don't need to know it. Actually, you can easily transform this logic to any other framework. So, let's get started. If you have cloned the app from the repository, we will start at exactly the same point. This is a standard Angular project with Angular material added to simplify the creation of UI elements. The structure of this app is very simple. We have folder pages which contain the components that represent each module of this course. So it's easy to go back later and find specific solutions. At this point, these are just empty standard Angular components, which we will define later. But they are already linked to the routing. Here in app routes, routes are defined, and in nav there's UI component which displays each of this route, okay? And app component implements the basic layout of this app using Angular material components. There we have a router outlet which displays these pages. Okay, so now let's start with the basics of Openlayers. First, we want to add an OpenLayer library. To do this, we want to use npm install OpenLayers. And if you are not using TypeScript, you are good to go. But in our case, we will need some types. And to add types, we will need npm install as dev dependency types Openlayers. Unfortunately, the types for Openlayers are not always correct or complete, so we will use this ignores or typecasting a lot. Now, to display basic map, we should go to the app component and create the core Openlayers component. Okay, so let's go to the app component and first create some div container in which map will be displayed. Okay, so let's add div with ID of map and maybe add some class. Let's call it also map. Now we will go to the app component class and start implementing the core OpenLayer components. Okay, we're gonna need some implements after view init. We're gonna need after view init because we need our view to be initialized to be able to reach this div. Okay, so ng, as you can see, I'm using GitHub Copilot. You can see some hints displaying on my screen, but it shouldn't be distracting, so I will keep it. Okay, so ng after viewing, and let's create a new map. New map will be imported from import app from, okay. Okay, and map class takes few arguments. First argument, first parameter actually is gonna be target. As you can see, target accepts string or HTML element as the value. For now, let's just use string, and string must be the ID of the element in which map will be displayed. Okay, so for now, let's just add string map. For now, we want to display just simple OpenStreetMap background. So layers takes array of layers which should be displayed. You can define all layers on the start or add them later dynamically, but we will cover this later. For now, let's just add tile layer with OpenStreetMaps. Okay, layers, new tile with source, new OSM, but we will have some error, and it is because I imported this from the wrong source. So let's fix this layer/tile. Okay, that's correct. And OSM, it will be imported from source OSM. So at this point, this should probably work. Let's see. But we don't see anything. And it's because I didn't add styles to map. This container should take all the available space, so let's just add with 100% and hide 100%. So to our map to be displayed, we also gonna need one last property, the view property, which contain information about center point, resolution, and rotation of the map. So let's add it. View, new view, which takes a lot of arguments, as you can see. Mostly you will use probably center point and zoom, which specify the initial zoom of the map. Okay, so for now let's just set center point to 0, 0, and let's say zoom to 2. Okay, so let's see if our map's being displayed correctly, and here it is. But we can for now hide the default controls of this map, and to do this we can just pass controls and pass empty array. Okay, and that's how in most cases the definition of the basic map component will look like. There is one more thing we can improve. I believe in Angular much more convenient way is passing HTML element as target. So we can do this using view child map, and map is type of element ref, which is referencing to HTML element. Okay, and we also need hashtag map here, and we can pass this as a target native element. It should work as previous, and yes, it works just as before. I would like to cover one last thing in this episode, as this will save you problems in the future with positioning of the elements. Okay, so the view element has property projection, and by default it takes projection EPSG 3857. Okay, so what is the problem with it? The Earth is shaped like geoid, but our maps are two-dimensional. So this is where projection comes to the rescue. A map projection is a way of mathematically representing the three-dimensional surface of the Earth on a two-dimensional map plane. The choice of the appropriate projection depends on the purpose of the map and the type of the analysis to be performed. When working with open layers, you will mostly use two projections, EPSG 3857 and EPSG 4326. What are the differences? EPSG 3857. This is a Mercator mapping adapted for displaying maps on the web. Coordinates are given in meters, counting from a point 0, 0 at the intersection of the equator and the zero meridian. It distorts surfaces the further away from the equator, so our areas closer to the poles appear larger than they really are. In example, Greenland looks larger than South America. It is used in Google Maps, Bing Maps, OpenStreetMaps, and others. EPSG 4326 is a geodetic system based on the Earth ellipsoid. Coordinates are given in degrees, latitude and longitude, and it is not a projection, it preserves the true proportions of shapes, but is not directly suitable for measuring distances or areas on a map. And for example, it is used in Google Earth. Now, we can check what is the difference between these two projections. Now we have the default projection set. If you are using this default projection, you don't have to write it here. Okay, so as you can see, it looks correct. But if we change it to 4326, the map will look like this. So as you can see, it doesn't look correct. It is because OpenStreetMap by default needs to use projection EPSG 3857. So that's it for now. If you like this video, please leave a like, subscribe, put some comments, and see you soon.